So 4.3 graph using intercepts. So I think overall this is probably the easiest method of graphing. It's probably my favorite. So an x-intercept, and a lot of times you'll see me abbreviate this as like xint for intercept. The x-intercept is where the graph crosses the x-axis. And then the y-intercept, and similarly I'll write it as y-int a lot, is where the graph crosses the y-axis. So then relating intercepts, points, and graphs. So this will kind of just be another way to write what I've already written up there, but so I'm going to do a little column for intercepts, then I'll have one for points, and then I'll show a picture of the graph over here on the side. I'll go ahead and set it up and then I'll fill it in a minute. All right, so intercepts. So the first one, the x-intercept of the graph is A. And I'll go ahead and do this. The point, so the graph crosses the x-axis at the point A0. So that would be like somewhere over here, just as an example, would be the point A0. So that's my x-intercept, is where it's on the x-axis. And then for y, the y-intercept of the graph is B. And the graph crosses the y-axis at the point 0B. So we can say that somewhere up here. This would be the point 0B. And then to graph the line, so basically you will find both intercepts and then you'll just graph the line through the 2 points like that. I use a cover-up method to solve the problems. Where I'll cover up one of the variables and solve for the other one, because that's all we're doing. So with that, we cover up one of the variables. And solve for the remaining one. Then cover up the other and solve for the first one. So the first problems that we're going to do are just finding the intercepts themselves and just telling what the x and the y intercepts are. And then the second part of it will actually be graphing them. So these ones first just say find the x-intercept and y-intercept of the graph. But we don't have to graph them yet. So number 4, we have 5x minus y is equal to 35. So it wants us to find the x-intercept first. If I want to find the x-intercept, I'm covering up the y value, okay, is my cover-up method. So I literally just put a finger over it, cover it up. So then I'm solving the equation that's left over that you can see. So my x-intercept, I will have, or to find it, do it this way. I'll have 5x is equal to 35. So that's what happens when I get rid of the y value there, is I'm solving the remaining equation. So how would I go about solving now 5x is equal to 35?
Divide.
Yep, divide by 5 on both sides. So x is equal to 35 divided by 5 is 7. So my x-intercept is 7. So if we were graphing it, we would set up our graph. I would go to 7 on the x-axis and put a point. So then I need to find the other variable, so I'm going to cover up my other variable, so I'm going to cover up x. So now I'm solving the equation negative y is equal to 35. So then how do I get y by itself? So it's like negative 1 times y. So how do I undo that? Yep, divide by negative 1. So y is equal to 35 divided by negative 1 would be negative 35. So this one would be pretty brutal to graph unless you changed like what each block of your graph was equal to, because otherwise you're going to literally use a whole piece of paper. So like I would probably count by 5s if I was going to do that. But your y-intercept then is negative 35. All right, let's see. 6. Negative 3x plus 9y is equal to negative 18. So to find my x-intercept, I'm covering up the y. So the y one is gone. So I have negative 3x is equal to negative 18. So how do I solve for x?
Divide by 3, negative 3 on both sides.
Yep, divide by negative 3. So x is equal to negative 18 divided by negative 3 would be positive 6. So my x-intercept is 6. Then y-intercept, I'm now covering up x. So I'm left with 9y is equal to negative 18. And how do I solve for y? Divide by 9. So y is equal to negative 2. And that would be my y-intercept. So that one wouldn't be bad to graph. That one's not like obnoxiously large. I told one of my classes the other day they were graphing something, and I said, I try not to give you really big numbers or fractions. And on their quiz, what did I give them but a really big number? unintentionally, but it happened. So our graph went like down to like negative 25. I was like, oops. They were like, yeah, I thought something was wrong, but I checked my work, and I was like, no, you were right. I just gave you a really big number on accident. Let's see. Number 8. 2x plus y is equal to 10. So what do I need to write for how to solve my x-intercept? Or what's my like new equation to find it? Yep, 2x equals 10. So we covered up the y and we wrote down what was left. So 2x is equal to 10. And then what? Divide by 2. So x is equal to 5. And then how about my y-intercept? Y equals 10. Oh, that one's nice because that one's already solved for me. All right, I'm going to show 10, but I'm going to also modify it a little bit just because. But number 10, we got 3x plus 0.5y is equal to 6. Now, what fraction gives me a decimal of 0.5? Like if I said reduce this fraction down, what would the most basic fraction be that gives you 0.5? Okay, 5 over 10 would be, so, and then if you reduce 5 over 10, what would that give you? How many times does 5 go into 10? 2 times, so it'd be 1/2. So I'm gonna rewrite this problem. This is how it was given to you. If I were to give it to you on a quiz or a test or something, I would give it to you like this. Okay. I'm not gonna give you any really hard ones, but 1/2 is a pretty easy one to deal with. So that would be what I would modify it to look like. Okay, so this would be a modified number 10. So let's do x-intercept first. So what would my new equation be to solve for the x-intercept? 3x equals 6. And then how do I solve for it? Divide by 3. So x is equal to 6 divided by 3 is 2. So my x-intercept is 2. How about y?
1/2 y equals 6.
Yep, 1/2 y is equal to 6. And then how do I solve for that one? Huh?
Would you still divide?
No.
Would you multiply it, or you would flip it?
Yeah, so I'm going to multiply it by 2. So remember, if we have a fraction like that, we multiply by its opposite, so basically 2 over 1. So everything cancels over here, so this is being multiplied by 2. You can write over 1 if you want the over 1 part. You don't have to write it because it just makes it a whole number. So then everything canceled on the left, so then y is equal to 6 times 2 would be 12. So that's all that you would do if there's a fraction in front, is you're just multiplying it by. It's like, you know, multiply it by its reciprocal, or it's flip from keep change flip. All right, one more of these. So number 12, we have y is equal to 2x plus 24. So something I didn't necessarily say about this problem, but maybe you noticed about the other ones, are that the x and y are both on the same side when we initially do these problems. So if they aren't on the same side, I need to move whatever variable over to the other side. So I have my my variables on one side and then my just numbers that don't have any variables on the other side. So I need to move my 2x over here with the y. So how do I move the 2x from this side to this side?
Subtract 2x on both sides.
Yep. So I'm going to subtract 2x on both sides. So I'll have negative 2x plus y is equal to 24. So then now I can set it up and find my x and y intercepts. So x-intercept would be what? Or set it up would be what?
Negative 2x equals 24.
Negative 2x equals 24. So then divide both sides by negative 2. So x is equal to 24 divided by negative 2 would be negative 12. And then y-intercept would be what?
Oh, y equals 24.
Yep, y equals 24, and there's nothing else I can do to that one, so we could just leave it. All right, I'm going to jump down to a couple other problems of looking at graphs that are given to you. And then tomorrow we'll actually do this, and then we'll take it the step of we will graph them. So I think that's kind of a good way to break this section up. But 28, we have, I'm going to draw the graph that's given to you and then tell you what we're going to do. So we have, oops. And these are increments of 1. Good enough. All right, so my x-intercept is going to be the red dot and the y-intercept is going to be the blue dot. So what would this point be here? 2, 0. So that means that my x-intercept is 2. So this is my x-intercept. Then my y-intercept here, what is this point?
0, 1.
0, 1, so yeah. So 0, 1, and that would be my y-intercept. And then, let's see, one more of these ones. Yeah, so it graphed it for you, and you had to tell what the intercepts were. So I just wrote them as points instead of saying the x-intercept was 2. It's the only difference what I did. All right, so then this one, same thing. They give you a point here, then a point here. Oh, that's not it. So what would my x-intercept be for this one?
Negative 4, 0.
Negative 4, 0. And how about my y-intercept?
0, 3.
Yep, 0, 3. So the only reason I'm writing them this way is just so that you see what the actual point would be that's getting graphed, but it would still come from like how we did in the first set of problems where we're finding the intercepts. X-intercept just means that y is 0, y-intercept just means that x is 0. So. All right, so the problems then that I would like you to practice today to get ready for stuff tomorrow for us to actually graph them. So basically, we'll just be adding a step to these problems tomorrow. So, let's see, 5, 7, 9, 13, and then 29. And then, like I said, tomorrow we'll graph them.